Okay, you finished counting all the water on your map. In a minute, we're going to use stickers to make a bar graph that includes the results from all the maps. Discuss this question. Here's our strategy. We decided that each sticker stands for 50 squares of water. That takes the number of stickers you need way down. Okay, go to the next step. Now, do questions 4, 5, and 6 on your worksheet to figure out how many stickers you need for each type of water. Remember, you need one sticker for every 50 squares, but you might have some leftover squares. Let's do an example. Let's say that you counted 238 squares of salt water in question 1. So write that number here to remind yourself. Then you're going to divide by 50, so do some long division. 50 goes into 238 4 times, but not cleanly. 38 is left over, it's the remainder. So in question 4, you have 4 stickers with a remainder of 38 squares. Okay, so go for it. If you're working with a partner, help each other out with the math and double check your work together. Now, let's see how many squares of salt water are on the map of Earth. Look at question 4 on your worksheet. Does your answer match Pat's answer below? If your numbers don't agree and you think Pat got it wrong, let us know. We suggest you use Pat's numbers now. If you're in a class, your teacher will have someone who has counted each map come to the graph and put up the right number of saltwater stickers. Teacher, use your master checklist to call up the 18 maps one by one. Make a check mark on your checklist as a map's stickers are added. If no one has some of the maps, don't check them off. Just skip them for now. Are there any maps that have not been checked off for saltwater? Add those map stickers too. We're almost done with the saltwater. I'm going to add up all the remainders for you now so we can figure out the final number of stickers to add. Have someone add stickers to the saltwater graph. Now let's see how many squares of frozen freshwater are on the map of Earth. Look at question 5 on your worksheet. Does your answer match Pat's? Put up each map stickers. Teacher, put up stickers for any missing maps too. If your numbers don't agree and you think Pat got it wrong, again, let us know. We suggest you use Pat's numbers now. We're almost done with the frozen freshwater. I'm going to add up all the remainders for you now, so you know how many more stickers to add. Have someone add those stickers to the frozen freshwater graph. Now it's time for the all-important freshwater. Look at question 6. Did you have enough squares to get a sticker for the freshwater graph? Raise your hand if you do. No one has a sticker. No one has 50 squares? How about 40 squares? Raise your hand if you have 40. No one? All right, how about 30 squares? 20? Go to the next slide and we'll figure out what we should put on the freshwater graph. All right, here's Pat's count for freshwater. Add them all up. Do you have enough squares for a sticker now? When you counted up all the squares, you saw that all of the world's biggest lakes don't even make up 50 squares. But there are lots of smaller lakes and rivers that were too small to show on the map. We've estimated that the smaller lakes and rivers on the globe take up at least 9 squares of fresh water. Now there's about 50 squares altogether. Have someone put one sticker up for the freshwater graph. Now your graph is done. Discuss, then advance the slide to watch the final video. The Earth is sometimes called the blue planet, and with good reason. It's a watery world. If you were to go to outer space like an astronaut and orbit above the Earth, there's a point high above the Pacific Ocean where you can see a view like this. This is a real photograph taken of the Earth from far away. Imagine if there were an alien seeing our planet for the first time from this viewpoint. That alien might think the entire planet is just water. That's how vast the Pacific Ocean is. Now, maybe you noticed that when you were counting the squares on the map, you were figuring out the area covered by water. But just looking at the area or amount of surface doesn't really tell you how much water there is. Because you know that lakes and oceans aren't just things on the surface, they're deep too. They have volume. So, to figure out how much water there is on the Earth, we actually need to look at both area and volume. Well, the deepest freshwater lake in the world, Lake Baikal in Russia, is about 1 mile deep. Now remember, that's the deepest lake there is. Most lakes aren't anywhere near that deep. The ocean, on the other hand, on average, is almost 2.5 miles deep. And at its deepest point, the ocean is almost 7 miles deep. So if we looked at the volume of all the freshwater and the volume of all the saltwater, that would really just make things slightly more dramatic than what you saw today. In other words, just considering the area and not the volume is good enough for estimating the difference between saltwater and freshwater on Earth. Now, here's what we found when we added it all up. Of all the Earth's water, most of it is the saltwater of the oceans. Only a tiny amount of that is fresh water. And of that tiny amount of fresh water, a lot of it is frozen and not easily accessible to us. It's in the form of ice caps that exist over Greenland and Antarctica. It's just the freshwater of lakes and rivers that's sitting on the surface. That's in a form that we can scoop it up, purify it, use it for drinking and for watering crops and animals, and for all our other uses of water. Only 1% of the world's water is liquid fresh water. Is that enough fresh water for everyone? There are 7 billion people on the earth, over 300 million people in the United States alone. Well, cities like Chicago and Cleveland in the United States, they're right next to these giant lakes, the Great Lakes, they're called. These are freshwater lakes, and that's the source of water for these cities and for the suburbs around them. So there's no major problems getting access to fresh water in those places. What about other places, though? Not everyone lives close to a lake or river. Maybe if giant lakes like North America's Great Lakes were divided up and spread out across the land, then sure, people might live within walking distance of fresh water. But that's not how the world looks. And most places in the world don't have giant freshwater lakes like these, as you could see on your map. In fact, there are huge sections of land that don't have any obvious, easily scoopable freshwater nearby at all. For most of history, getting easy access to fresh water has been such a problem that it has determined where we could even live and build cities in the first place. All the old large settlements were started near a source of scoopable fresh water, like lakes or rivers. Today, though, people manage to live just about anywhere. There are major cities in the United States, like Los Angeles and Denver. Neither of them have big lakes or big rivers nearby. In fact, most people in the world do not live within walking distance of scoopable fresh water. So, where do they get their water from? You'll find out in the next mystery. Have fun and stay curious.